Okay, so we're going to talk about perspective drawing, and I do want you guys to be aware that this isn't something you're going to be able to master in this class. We're just going to do an introduction to it and a few exercises to get you guys familiar with perspective drawing to get the basics of it. If it's something that interests you, or if you're wanting to work in animation or architecture or interior design, this will be something that you will need some more studying with. And I'm going to give you guys a bunch of information so you can have quite a bit to reference. But just so you know, we're not going to cover a ton of perspective. We're just going to do a little, just an introduction for you. Okay, so some terms just to get you familiar. The perspective plane is an imaginary surface plane which is perpendicular to the spectator, on which the subject is projected. Think of it like the image you see when looking at a picture frame. Okay, the horizon line. Hopefully this is very obvious, but just so we have the terminology for it, it is where the sky and the earth meet. Now the cone of vision deals with the amount of information that you can see clearly in front of you. So when we're talking about perspective, we're going to be talking about dealing with realistic looking imagery. As you go on to make drawings, if you're more interested in fine art, maybe accurate perspective isn't something that you're worried about in your drawings, and that's fine. I just want to make sure you guys all have a basis of understanding for this in case you would like to draw realistic forms in perspective. That way you know what you're doing. So you can read through this more carefully on your own. As a reminder, all the lectures are uploaded with the PDF copies. But basically the cone of vision is the amount of information that you can see clearly and accurately without distortion. So your eyes can see 30-degree radius. So you can see up and down and side to side, right? So that creates the cone shape coming out of your eye. And since we have two eyes and they can focus for 30 degrees, that means our cone of vision is 60 degrees with both eyes together. Everything else outside of that falls into your peripheral vision, which you can see out until about 45 degrees. And everything outside of this cone of vision from the 30 degree to the 45, which is the extent you can see side to side and up and down, all of this will be distorted if you were to draw something that existed on either of these sides. So everything inside the cone of vision would be accurate. Eye level refers to the height of the viewer's eyes are positioned in relation to the ground. There are various eye levels depending on whose point of view the scene is being viewed from. Okay, so here's an example of various eye levels, right? So if it's going to vary depending on the height of the spectator. Excuse me. The eye level will also shift if the spectator goes up or down something like stairs, or in this example, in a helicopter, right? So it'd be literal where the actual eyes of the spectator are. The ground plane is always the same, the horizon line. It's always where the earth and sky, or sea and sky, meet. The eye level remains the same even if you tilt your head. The spectator tilts their head up or down. Okay, vanishing points. In linear perspective, a vanishing point is a point or points, depending on which system, at which receding parallel lines appear to converge into space at a point in which they meet. So in 1-point perspective, the converging lines recede to a single vanishing point on the eye level. In 2-point perspective, the converging lines recede to 2 vanishing points on the eye level. In 3-point perspective, the converging lines recede to 3 vanishing points. Similar to 2-point perspective, 2 of the vanishing points exist on the eye level, while the third vanishing point exists either above or below the eye level. And we will get into more detail of that in a minute. Vanishing points are where all converging lines meet.